Today we're looking at trigonometric ratios in right triangles. We're going to start out with the very basic, very simple ratios. Trigonometric ratios are ratios of the lengths of the sides of a right triangle related to the acute angles. When we're looking at a right triangle, we have to be able to identify different side lengths. There are three that we have when we're talking about trigonometry. We have the hypotenuse, the opposite side, and the adjacent side. The hypotenuse is the same as it has been when we've been studying right triangles. It's the side that's across from the 90-degree angle. I normally label that with an H. Now the opposite and the adjacent sides depend on which angle that we're working with. If it tells us find the sine of A, we're working with angle A. So I go ahead and mark an angle that we're working with. In this case, we'll say it's A. The opposite side is a side that is straight across from that angle. Side BC, in this case, would be your opposite side. I normally label that OP for short. Then your adjacent side is side AC. It's the side that's actually helping to make that angle right here. I normally label that one A or ADJ. The thing to remember, though, is that opposite and adjacent is relative to the angle that you're working with. So if we were to change angles, the opposite and the adjacent sides would change. It's all relative to the angle that you're working with. The three most common trig ratios that we'll work with are sine, cosine, and tangent. Sine is abbreviated SIN and is the ratio of the length of the opposite side to the hypotenuse. So many times we say that sine is the opposite over the hypotenuse. Cosine is abbreviated COS. It is the ratio of the length of the adjacent side to the hypotenuse. Oftentimes, we say it is the adjacent over the hypotenuse. And tangent is abbreviated TAN, T-A-N. It is the ratio of the length of the opposite side to the adjacent side. A lot of times, we say O over A. So let's look at our first example. Example 1 says find the sine of A, cosine of A, tangent of A, sine of B, cosine of B, and tangent of B, and to express each ratio as a fraction. What I need you to do is I need you to change the S and the E's in your table. Now let's look at the problem. First, we're going to start with the angle A. That's our angle, so that's what I'm going to mark. Now we need to label each side as far as hypotenuse, opposite, and adjacent. The hypotenuse is always across from the 90-degree angle. It's the longest side in our triangle. This would be 13, or side BA. Next, we need to label opposite and adjacent. Remember, opposite is across the triangle from the angle. What I mean by across, if I drew a line straight across to the opposite side, that's our opposite value. So 5, or BC in this case, would be our opposite side. And the adjacent is the side that's left, or it's the one that is actually touching the angle, right here. So let's write out our fractions, our ratios. One thing that you can do is go ahead and write a table out to help us remember what our ratios are. I always write my table just like this. SCT at the top, and then I remember our ratios. O over H, A over H, and O over A. We can use a mnemonic device to help us remember this one. My teacher in high school taught me to say Oscar has a heap of apples. I know it sounds silly, but it's something that helped me remember trigonometry. Other people use SOHCAHTOA or OAOA. Whatever you're most comfortable with is what you should use. So we see that sine is the ratio of opposite over hypotenuse. So our sine value would be our opposite, which in this case is 5, over our hypotenuse, which in this triangle is 13. Our cosine is the adjacent over the hypotenuse, and we see that right here. Our adjacent in this triangle is 12, and 13 is the hypotenuse. So our ratio is 12 over 13. Now our tangent is the opposite over the adjacent, which is right here. Our opposite in this triangle is 5, and our adjacent is 12. Now we have to find all those for the cosine, or for the angle B. Well, first we need to label everything for angle B. Mark the angle you're working with. In this case, we're going to be using red. Our opposite and our adjacent angles, or adjacent sides, change. So the sine of B is our opposite, which in this case, is 12. And our hypotenuse stayed the same. So it's 12 over 13. Our cosine is our adjacent over hypotenuse. Our adjacent here is 5. So our cosine of B is 5 over 13. And our tangent is the opposite over the adjacent. Our opposite again is 12. Our adjacent again is 5. So our tangent of B is 12 over 5. Now, I want you to try example 2 on your own. When you have it finished, check and make sure that you have it done. Just pause the video and then hit play after you're done. The sine of angle S is 3 over 5. The cosine of angle S is 4 over 5. The tangent of angle S is 3 over 4. We got those because we labeled our sides as such. If we work with angle E, remember our opposite and our adjacent switch. So our sine of E is 4 over 5, our cosine of E is 3 over 5, and our tangent of E is 4 over 3. Did you get them right? I hope you did. If you didn't, take a look back at the last slide. If you have any questions, please don't hesitate to email me.